Yeah, what I'm going to do now is I'm trying a feature which I've never used before, so it could be that it won't work for the first time. Yeah. Therefore, I will start a sketch. So for those of you who do not know how to use Inventor, there are tons of videos, tutorials out there, so just watch them and get to know the software. What I was doing here that was just taking the right view for the part, because now I will add something, and it was somewhere here, and it's called equation curve, and if everything works out well, we will have a working equation here. So I've calculated them before, so they fit, and yeah, the equations are planned by different points I know of the drive system, and they build the link between those single points. Yeah, and I'm just copying this equation now. It took us some time to calculate them, so I think 4 people were trying to solve all those equations for, I think, a few days, because we always had different solutions and we didn't know which one was the right one. The exact way you can read in our engineering notebook, and so that really does not look like the thing I want to have. I will just look up a thing. Give me a second. I think that didn't work out as well. Yeah, this looks more like the thing I was expecting, and yeah, so it's 350 in both directions. Oh no, 175, so yeah, this looks great. And so this is the first equation curve for the system here, and but I'm still not like it. So T, I have to copy it the next time. So sometimes I'm not talking really much if I'm concentrated, so those parts are just for you to listen to the music and yeah, enjoy watching the video and just see me doing the construction stuff. Yeah, this is nearly what I am expecting, and then I have to get this is 0. this is a quarter. Yeah, this is a quarter of 350. Yeah, so for you to know what I'm doing here, maybe it would have been a better idea to show this to you a bit earlier. But yeah, so this here is the thing I'm trying to bring to Inventor. So imagine this part here is not existing, the whole part under the x-axis is not existing, and just those two lines and also this line are building the system for the wheels to be attached. So there will be one wheel here, and one wheel here. Always would be motorized, and yeah, so yeah, this is the first equation for this. So here will be a point of a wheel to be attached. Here will be the point where the so-called boogie is attached. So the rocker boogie drive system is the front wheel here is the rocker, so this one is climbing over the rocks, and the boogie is running behind it and just holding the the robot or the car over the ground. And yeah, because that did work out very well, I will directly type in the second one. So this is sorry, I'm a bit tired. It's late in the evening now, so yeah. I hope I will not do too many mistakes while I'm building this robot. What means building? Yeah, planning. 10 times 6. So, and this one is also from minus 1/4 of 350 to 1/2 of 350. So, and here you can see now the basic form of the connector. Now I will add a little offset, which is not working, out of which reason. It's working to the inside but not to the outside. That's a very funny thing. I think I have to move this one here. Yeah, that's the thing I wanted to see. And this should be first I maybe measure thing. So for measure you can use M. Or also D. So 216 millimeters. Yeah, that looks fine. Yeah, that's great. Yeah. So this one should be around 25 millimeters. So for all our American viewers, I just want to remember that this here is the metric system and we are calculating in millimeters, not that you are confused because there's a 25, it's in millimeters. It's not 25 inches, because that would be a little bit too big, just a little bit. Oh, wait. Wait. So, yeah, just want to have this line here. Is this possible for you? I think not. Okay, maybe we're going to... Okay. He's not willing to do this, but that's fine. No, it's not fine, but it's okay. I have to deal with it. No, I won't deal with it. I think 25 a little bit too much. Maybe we'll do 10. That's better. And then we will offset into this direction, also 10 millimeters. And then we will add the lower part here. So do not wonder what all those lines here mean. It's just I will trim this line here with this line, and also this line here. Right. So no, stop, was the wrong thing. I have to trim this one here. So maybe my team decides to just make the videos as time-lapse. Maybe we will also do both, so time-lapse and the normal view. So sometimes it's willing, sometimes not. This here is just a line for construction purpose, and you can here search the constraint that it's no, it's not working. There was a something where you could do this. Oh wait. I think this one here. So I will, yeah, okay, it's not letting me do this, so, yeah, this looks good. So sometimes if you just see, me doing some lines here, it's, yeah, kind of like testing things, and I'm then trying to, yeah, find an optimal fit for some parts, and yeah. So this here is the fixing point. So here I will add a circle. And this circle should be a little bit bigger. I think this is a very good. Oh no, it's way too big. But this one here is way too small. I think 40 is a good one. So what you can't see is I always have some rulers and measuring tools laying around here so I can see the measurements I'm typing into the computer. And yeah, you'll have to always remember this, that this one here is the base sketch. So on this sketch the rest is depending. And oh, sorry. So yeah, this is enough as a base sketch, and this section here you can see again with, all things without dimensions. Let me just have a quick look at the time. Yeah, it could be that the episodes are a little bit longer. Yeah, this is depending on how much time I need to do all the yeah, drawing process. So it's truly possible that a part needs could need is between an hour and yeah, some more. Those ones here should be so, yeah. So I will make those two ones collinear. That was not what I was thinking of. So I'm adding dimensions now that it couldn't get the idea to. So this program here is very annoying sometimes. So if those blue lines appear, the sketch is fully defined, so there's nothing which is not which is undefined left. So all parts have a fixed measurement, and so I hope the program will do the. No, still not. Okay. I hate this program. Sometimes there are some things not working, like you want them because the line is not like the program wants the line to be, and now it is. So because this should be a very stable 3D printed part, we should use a good strength of maybe 15 to 20 millimeters. I will take 20, and you could see that the sketch is now hidden, so I will make it visible again to also extrude this part here, also with 20 millimeters. So in the extrude function there are different different options. You can change directions in which direction you are extruding. You can say that you want to join the two bodies, so if a new extruded part cuts in a other body, they will join together as one new body. You can also cut them, so you then cut out of the existing body the shape of the new body. You can also do intersection, so then just the part which both bodies do have will survive. And I will now use join, so you can also do a new body, but in this case it's not needed. I will use join, and now you see we have here this part. But if I will print this part, it would be very heavy, and also very it will cost a lot of material to print this, so I will add some holes in it. Therefore I'm going to do a sketch on it. Will again add my my little equations. I like them. I needed so long to calculate them. I can see them, but this one should be construction. So what I'm doing here is every part has, if you get a force here and a force here, the outer side here will be pushed together, and this side here will be pulled. And if you put a pressure coming from here, so this part has to be fixed, of course, but if you put a pressure coming from here to down here, the upper side will be pulled and the underside will be pressed together. And in the middle there's the neutral zone, so they can drill holes as you want and nothing will break up. And we also shouldn't forget that we have to add our hole for mounting this thing. This one will be somewhere around here, and I have to look up where the center point is. Here's just the construction line. Then I will also add this construction line, and there's a distance of 21.85. So there's another not funny thing on drum keyboards. In the right number section, the dot is a comma, so yeah, it's not fun typing in measurements with this kind of keyboard layout. So now I will drill holes because I like drilling holes in things, and I first have to place some points here. So this point here will be the mounting point, so there the whole thing will be mount it. And then I will have a point here. So those holes should be there to save weight, and also material. So in most cases weight equals material. And there should be a bigger hole for mounting the So what I'm doing here is a little stress analysis, just for me, yeah, to know if the thing I was looking for, yeah, so if the holes are okay like this, or if they aren't, if they cost too much material for stability. Okay, yeah. Maybe I should define a material. So now I've configured the study and I will let it run. It's possible that it will fail the first time, but you can see we are still in the safety area, and you can see here that it will be a little bit deformed, but it's 10 newtons forcing onto here, so that's very much and I think I have an idea what I could still do without losing too much safety. So all those added things have a direct effect onto the behavior in the stress analysis. I do not exactly which effect, but they will have one. So yeah, this part is more or less finished now. There are some little details missing concerning the mounting of the single part. So, but those details I can then add when I know which how the other parts look like. So. Yeah, as always, if you liked that video, even if I was not talking all the time, hit the subscribe button. Do not forget to hit the bell right next to it that you do not miss any of our next videos. If you want to know more about the team, visit our webpage. It's ftc.hhg-kl.de, and yeah, maybe you leave a thumb up here, and see you next time.